1, 2, 1, 2. Check, check. I am the great and powerful Oz. Other pithy things. Fourscore and 7 years ago, our forefathers brought forth upon this continent a new nation, conceived in liberty and dedicated to the proposition that all men were created equal. And that's all I remember from the Gettysburg Address. If anyone is actually hearing me on YouTube and is wondering why I'm saying these things, it's because we're testing the audio. So we'll get it all sorted out. When I talk.
Yeah, allow mic.
I don't always talk on YouTube, but when I do, I test the audio extensively.
I think my fear is something that's happened to us before is it's been really quiet.
Yeah?
So I think you're talking, but I need to actually go in and talk to you.
Pump up the volume, pump up the volume. I don't want to sing that too long or, it might get censored.
Oh, Dave Jard did that. He came out of the stream and started with like, celebrate. And like we had a strike instantly.
Yeah. So if I just sing it really badly out of key.
You need to be like Weird Al Yankovic.
So we're gonna.
Oh, but I want to sing.
I get no kick from champagne. One test, two test, red test, blue test. Wait a minute, that's not right.
We didn't do our test at the front. Now we're trying to count them all in at the last minute before we go on.
One code, two code, red test, red test.
Can you hear it? Yeah. You can hear it.
Check, check, 1, 2.
He's good.
I'm on the YouTubes. Hooray!
So you can stay there. I'm never too concerned about being on
Okay.
I'm not pretty enough.
I'm not either. That's why I've got the beard to hide it all.
Oh, yeah. That's
Everyone just sees the beard and the hair, and then they,
all right. So, Bigfoot. Right. So tonight we have Bigfoot. Is that saying how to find Bigfoot?
roar! I'm actually only a size 11.
Really?
Yeah.
Oh, man. Anyway, guys.
Sorry, did I totally steal your thunder? It's like, Bigfoot, what? Size 11? Okay, so, welcome. How's everyone doing tonight? Good. See, we got, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'll count him 19 people here. Plus whoever is out there grabbing up the tamales. So, well, my name is Guy Royce, and this is my talk, Machine Learning for Fun, Finding Bigfoot with the Nexosis API. And, no talk would be complete without a narcissistic slide. I'm a developer evangelist for Nexosis. And before I did that, I wrote software for a consulting company. And before that, I wrote software for an insurance company. And before that, I wrote software for lots of other companies, way back into the distant times of the early 90s. So I've been writing software for about 25-ish years, maybe 24. Math is hard. That's why I work in machine learning, because, math is hard, right? How many here know what a developer evangelist is? I've run into this term before. So the long and short of it is that a developer evangelist means that I'm working right now. So my job is to go out into communities and talk about machine learning, and if I can, talk about our product, and show people, just kind of get the word out about it, let people know it's there, and sort of be sort of like a little bit of brand recognition. Hey, oh yeah, Nexosis, I heard of them. Guy Royce came and did a talk and mentioned them. So that's kind of what I do. And so I go to user groups and conferences and stuff like that. And I mean, it's such a burden to be a developer evangelist. Just last month, I was in Virginia Beach at Revolution Conf, and the conference is actually at a hotel on the beach. And I got an ocean view hotel room for the talk that I gave there and everything. It's and then there's all the free beer at the parties and stuff. It's such a difficult job. Anyhow, So I got my Twitter on here if you want to follow me on Twitter, or if you want to make fun of me or mention me during my talk. You're totally welcome to do that. And as I say that, I'm going to put my phone on airplane mode so that I don't see any of them and get distracted. Feel free to interrupt me during the talk for questions. I'll try to repeat your questions so that it's recorded for the YouTube video and for anyone who's watching on streaming, and just so everyone can hear it. So if I don't do that, call me out on it. So I work for a company called Nexosis. And I'll read this slide here. It says, Nexosis is a company of developers focused on providing easy access to machine learning. And that's a picture of some of the people on our team. We actually have these blue track jackets that we're supposed to wear when we talk. But I don't have one, because it turns out they don't make track jackets for fat people. And so they couldn't get one to fit me. And so I just get the black Nexosis shirt instead. But all these people in this picture are developers, I think, except for Jen. She's got the pink hair. Actually, she's not with Nexosis anymore, unfortunately. But she wasn't a developer, but everyone else had written some code at one point in their life. So we tried to build a company of developers, build products for developers. And what we've built is a machine learning API, an automated machine learning API. So how many of you have spent any time at all messing around with some machine learning? Okay, what kinds of things have you done? You did some TensorFlow. What did you do with TensorFlow? Yeah. Okay, so you did some tutorials. So that's actually pretty common. I mean, I've done that. I haven't gone deep into TensorFlow either. I went through and did a couple of the exercises, and I followed all the steps, and it did the thing at the end it said it would do, and that's as far, but I didn't actually learn a lot. And I think that's a typical experience. I'm guessing that was yours as well. You're nodding, so. Anyone else? Yeah. You did the Titanic example with Azure ML. How'd that turn out? Yeah? Yeah. Anyone else? I'll take a third one. Yeah. Okay. Yeah. So I haven't used MATLAB much. I'm actually not a very mathy person. And I've got this caveat on my talk. Anyone know what this stands for? I'm not a data scientist. I'm not a data scientist. So I don't have a strong math background. I don't have a strong data science background. I'm a developer. And now I'm a developer evangelist, but I've been writing software for the past couple decades. And honestly, if you look at software that you've written in your career, how much math have you used beyond basic algebra on a daily basis? Right? Not much. And so I don't have any deep math skills. So I've just lost all credibility. Now, odds are a lot of you took a lot of math in college and haven't used it since, or have used it for things that weren't for work. Like I know a friend of mine, he's like, well, I haven't used trigonometry forever, but then I was doing I was remodeling my basement, and I needed to figure out what angle I need to cut something at. And, oh yeah, I learned trig in college. But he never used it at work. So what Nexosis has done is sort of build a thing that's good for people who aren't data scientists. You upload your data to the Nexosis API. You then say, I want to predict this column, and these columns are features. It's just rows and columns of data. And and then we say, hey, predict this value. So you've got, say, housing data, and you've got lots of example houses. You've got features that affect those houses, such as like the square footage or the zip code, or maybe the lot size. And then you've got a value of the house, what it last sold for, or maybe a valuation. And you can feed it a bunch of those examples, and then it learns from those examples, and then you can ask a question and say, well, if I got a house with this square footage, with this lot size, in this zip code, how much should it be worth? And we basically let you upload that data and then ask the question without having to build a bunch of models. We'll try all the models. We'll build all the models with all the algorithms that are appropriate for your problem, and then pick the one that scores best for you and give you an endpoint you can call. And I'll show how that works in demos. I already said I'm not mathy. You can all boo me now. This is a terrible joke. I actually got this from Alexa. I said, "Hey Alexa, tell me a joke." And she said this. She said, "My math teacher called me average. How mean." So I'm not super mathy. I just never studied it. My career path never took me down that route. One thing I am interested in is Bigfoot. I think Bigfoot's kind of entertaining. How many here are familiar with Bigfoot? I'm guessing everyone's familiar with Bigfoot, right? For the most part, big hairy hominid, runs around the woods of the Pacific Northwest and southeastern Ohio and Florida and lots of other places that no one ever seems to be able to get a good photo of. And the only video we have is the guy who did the walking in the suit has admitted it. But I'm convinced Bigfoot's real, and I want to find him. And the reason I'm kind of obsessed with Bigfoot is that Bigfoot was my father. Well, he still is. And he left when I was young. And I've been trying to find him. If you've ever seen the World News report, that tabloid that's got all the really outrageous things about UFOs and Bigfoot, they've got a classic headline from it with Bigfoot, and this little boy that was running around with him in his whitey tighties. That was me. I was a lot thinner then. And so I'm trying to find my dad. And so trying to find my dad, it's, he's hard to find, so I thought I'd bring in the experts. So I went for those people that are out there finding Bigfoot. And we don't always find Bigfoot, but when we do, we don't. How many have seen this show? The Finding Bigfoot show? The four people on here, these people are the true believers, and this woman here is the skeptic. And you can kind of tell because she's the one that looks pissed off. She's like, "I can't believe I'm here with these stupid guys." But these guys down here are like true believers. They're really looking for Bigfoot. One of them actually has an organization which has been gathering Bigfoot sightings for the past 25 years, roughly, called the Bigfoot Field Researchers Organization. And so they've got a data set of all the Bigfoot sightings since like 1890. And they're just in a website like someone typed them up, but they're not very structured. So you go to the site and it's like they got some column fields that they filled in, some are empty, and it's all just a web app, right, that's showing these reports. And they were founded in 1995. And if you look at the website here, I think that's kind of obvious. I mean, it's got a black background. I'm expecting to scroll down and find like spinning skulls, and flames and everything. It's a very dated looking site. Actually, I've got the site up here. And so you can see that this is actually a real site, and it's apparently Bigfoot's in China too. There's the classic picture. Wasn't this a hoax? Yes, I watched the guy walk just like him. It was fantastic. All kinds of great stuff. And so if you go on their site here, you can look at like their sightings. Where's the link here? Sightings by region. Let's go to reports recently added. Watch the internet fail. So here's here's one in a Class B sighting, June 15th in Idaho, Madison County. Camper finds possible tracks on a sandbar along Henry Fork River. And you can click on them and get the full account. Right? And so there's all this data here, but it's not really in a format that we can do machine learning with, right? It's not very useful. You got to go and read all these individual accounts. They're kind of like police reports. And they've got all kinds of data. Here's apparently the location where he saw the thing here. Had the sighting, right? So that's their site. But it's not. That's a great question. I'm going to get to that in a moment. But there are classifications for Bigfoot sightings. And the question was, what's the difference between a Class A and Class B? And I said 1 minute. So it wasn't very useful data, though. So this guy, his name's Tim Renner, and he wrote some code to screen scrape all of the Bigfoot sighting data off of the BFRO's site. And he put it on this site called data.world. And data.world is sort of like, it's user-submitted data sets. So anyone can put anything up there. And he's got a penchant for weird data, is evidenced by his tinfoil hat. He's got a data set of haunted places that he screen scraped from, I don't remember the name of the site. He's got the Bigfoot sightings, which he screen scraped from the Bigfoot Field Researchers Organization. And he's got a data set of UFO sightings, which he screen scraped from the National UFO Reporting Center. He screen scrapes a lot. He writes Python, I think it's Python code to do this. He's got GitHub repos with it. And then he uses it to do machine learning as well. He is actually trying to find Bigfoot, and he decided to do clustering with the GPS locations. And so he takes all these GPS locations from these Bigfoot sightings, because that's one of the data points we have, and he plots them out on a map, and then he finds the natural groupings in it using a clustering algorithm. And they creates these natural groupings. He's trying to find some sense to it, and he put it over top of a vegetation map of North America, and determined that if you look carefully, you can find Bigfoot in the woods. That was his conclusion. The UFO sightings is actually fun too. I'm going to show you his site here. That's not his site. That is, yeah, here is his site. Go to the posts, finding Bigfoot. So there's all the plots that he put on his map. And there's the results of the clustering algorithm. So he found the logical groupings of them. And then he put them over top there, and you can see that it clusters in wooded areas. There's a bunch in northern Michigan, and of course, in the UP. Of course, Bigfoot's up there, right? You'll see that like almost all of Ohio and Kentucky and West Virginia are covered by, groups of Bigfoot sightings. And so, but yeah, he concluded you could find them in the woods, which I found kind of funny. The UFO stuff, he plotted it out and determined that 2/3 of all UFO sightings take place within 150 kilometers of an U.S. Air Force base. Imagine that. So, Air Force. And he also discovered that he made this histogram here showing this is just the absolute number of UFO sightings for each day of the year in his entire data set. And you've got this and so this is January 1st, and this is December 31st over here on the right. And all the way here, you got this big peak here, which is almost 1,400. Any guesses what day that is? Just North America. It's the 4th of July. Is that a firework or a UFO? Couldn't be a firework. There's also a spike on January 1st, which is another popular time to let off fireworks. So it's also worth noting both of these holidays involve alcohol. So he's done a lot of really cool stuff with this data. And so I've been playing around with it with our API because it's kind of fun. And I'm really actually incredibly grateful that he went to the trouble of screen scraping all this stuff so that I could use it. I mean, others have used it, but it's kind of cool that he did it. And it's just proof, right, that you can find anything on the internet. Like, we got a whole data set of Bigfoot sightings, UFO sightings. So here's what the data looks like that he gathered. You've got a date, and that's pretty useful for machine learning. We're going to use it for forecasting and impact analysis, and I'll get into what that means in a bit, but we're going to predict the number of monthly Bigfoot sightings. And dates are full of useful information in that regard because the month of the year is significant, perhaps for Bigfoot sightings. The day of the week is significant. When you're doing any kind of machine learning, there's all this kind of data embedded in a date. You've got the day of the week, you've got the day of the month, you've got the month of the year, you've got the week of the year. There's a lot of seasonality that comes with that date where, like say you were trying to predict sales at a pizza shop, right? You're going to have an upturn in sales towards the weekend. So Friday is a significant day. You're going to have an odd downturn, though, in November on one particular Thursday and Friday. Well, actually, who orders pizza on the day after Thanksgiving, right? Maybe people do. I don't know. I'm usually eating leftover turkey myself. So, but the date's super meaningful, super useful. The ID, this is a unique ID that's part of that data set. It's saying, hey, this is report number 8086, the original microprocessor that I first bought. And that's not super useful because it's unique each time, so there's no meaning in it. It's just an identifier. So for machine learning purposes, it's not very useful. We've got the report text here. The report text is the eyewitness account of the Bigfoot sighting. And so we can use that for natural language processing. And we're going to do that later in the talk as well. You were asking about the classifications. There are 3 classifications of Bigfoot sightings: Class A, Class B, and Class C. And one of the things we're going to do is we're going to use this here, the report type, and then, or the report text, the eyewitness account, and determine the class that it falls into using classification. So a Class A Bigfoot sighting means I saw Bigfoot. Right? Pretty easy. Class B is I saw or found evidence of Bigfoot, like a footprint, or maybe I heard a noise out in the woods or something like that. And there's also a Class C Bigfoot sighting, which there aren't as many of, and that means someone told me they saw Bigfoot, which is perhaps the most reliable of all the Bigfoot sightings. There's also latitude and longitude, which we're not going to use today, but is what Timothy Renner used to do his to determine that you can find Bigfoot in the woods. And there's actually another bit of data hiding in this data set. Any thoughts as to what that might be? No, not what continent. Yes, the number of sightings. The fact that we have a record means there was a sighting. And so they all have a quantity of 1. So it's sort of, the existence of a row is in itself information. And so we're going to use that quantity. We're going to aggregate it up monthly, and we're going to use it to predict future Bigfoot sightings. One of the things that we'll need to do that is we'll need to fill in the blanks of missing data. That's called imputation. So lots of times you'll have holes in your data, nulls, or you just won't have a record at all. And you need to fill that in with a meaningful value. And so in our case, we're going to impute them to be zeros, right? If you look here on the left, in 1958, we got 1 sighting in January. The February and March have no sightings. So when we need to fill in how many sightings do we have for that month, we just say, well, we didn't have any records saying there was or wasn't any, so it's 0. We're imputing a 0. And we can also aggregate these together. So we take these 2 sightings in December, and then we aggregate that in for December, because we want to do monthly predictions. So we can impute values by filling in the blanks with meaningful defaults. 0 is a great one for what we're doing. If you had sales, like say you had weekly sales data from the pizza shop, or daily sales data from the pizza shop, if you didn't have an entry for that particular day, then your sales is probably 0. That's a reasonable default. If you're taking daily measurements on the height of a plant that you're growing, like your corn or something like that, and you were missing a measurement for the week or the day, then 0 wouldn't be a reasonable default because it didn't go from 24 inches to 0 inches to 26 inches. That didn't happen, right? That's not reasonable. Or you're tracking your weight over time and you're trying to predict your future weight. You're not going to go from however much it is that I weigh to 0 to however much as I weigh minus 5. That doesn't make any sense, right? And so you can use other imputation strategies like the average between the last 2 data points, or just the average overall. You can take the mode. There's lots of ways to do it. So I'm going to talk about 3 types of machine learning, explain a little bit about what they are, and then show you how you can use our product to do it. So we got forecasting. That's predicting the future. You've got impact analysis. That's predicting the past and comparing it against actuals. You've got classification, which is putting things into categories. Is it a hot dog or is it a wiener dog? Is it a Class A, Class B, or Class C Bigfoot sighting? So let's do forecasting first. For forecasting, we're going to look at our historical Bigfoot sightings, and then predict Bigfoot sightings for the next 3 years. And my data set ends in 2016, so 2017 and 18 and 2019 are the years we're predicting. So here's what we get when we map out all those historical Bigfoot sightings. And this has typically been everyone's favorite slide, just because everyone wants to look at it and look for the patterns of what does this mean. On the far left here, you guys probably can't see it, but it's January 1st, 1950. And on the far right, we got 2016, 2017. So that's December of 2017. And each of these little boxes on here represents 1 year. And so you've got sort of like a low level here, and then it rises up in the late 70s, and then it drops down some. And then in the mid 90s, it starts rising up again, peaks around 2007, and then starts dropping off dramatically. Any thoughts on why these numbers might be the way they are? Yeah. More easy access to bad cameras in the 90s, as the reason that might be. Yeah, and then it went down because now we've all got wonderful cameras, right? With us all the time. I think that's part of it. More drugs? Well, that would certainly explain the spike in the 70s. Yeah. Actually, you think about the 70s. I'm probably going to point out that I'm old here, but I'm not that old, but I remember the 70s. I remember the 70s clearly, which is probably more true of me than my parents. But well, there was this sort of, it was part of the zeitgeist in the 70s, right? It was just kind of what everyone was. The 70s were a little weird. Like there was a show with Leonard Nimoy called In Search Of, which was all these paranormal things, and there was. I remember he always had the Easter Island heads in the intro of that show. There was the $6 Million Man episode that had Bigfoot in it, played by Andre the Giant. Fun fact. They did 5 episodes of the $6 Million Man with Bigfoot in them. They even made an action figure. It's fantastic. So Andre the Giant had an action figure made after him that wasn't about wrestling. So, but I think the 70s, it was just kind of what people were into at the time. Maybe it was drugs. Down here, once you get in the mid-'80s, people aren't taking Bigfoot as seriously anymore. That's probably because of Harry and the Hendersons. I don't know. Up here in the 90s, it rises again. 1995, that's about when the X-Files came out. So one of the things we're going to do for impact analysis is we're going to measure the impact of the X-Files on the number of Bigfoot sightings. And then it drops off. I honestly think this is that everyone got cell phone cameras and they couldn't lie anymore. That's my theory. But here's what our data kind of looks like from a sightings point of view. We've got a month. So we got 2015 and 2016 here. And we've got our quantities, and these go back to 1950. And then we can ask a question of saying, hey, based on all this historical values, all this historical data, what do we think the future is going to look like? Which is kind of what people do. And I will say that this data set is garbage. So we don't actually get great results out of it. And the problem is if you look at it here, it jumps all up and down, which is, it's hard to find a pattern in. But there's also no features that we're using to give it any guidance as to why it goes up or down. All we have are the number of Bigfoot sightings and the time. And so it can find a little bit of seasonality out of the date, but it's not going to find, well, we're going to expect long-term for it to go up and then down, and it's not going to find that kind of shape because we haven't given it anything to do that off of. It doesn't have enough features to figure it out. But it's a fun example. And I'm going to go ahead and do it with the Nexosis API here. So the Nexosis API's got 3 ways of interacting with it. We've got a dashboard, which you can kind of click your way around. We've got a RESTful API that you can call via HTTP. We'll use Postman for that. And it also has, we also have client libraries that wrap up that RESTful API. So this is a, we're a .NET group here, so we got a C# library that you can use. There's a jar for Java. There's a node package for JavaScript. All the popular languages are represented. And so the third example will be with that. But let's go ahead and use the site first. I'm going to go ahead and sign in here. guy.royce@nexosis.com. My super secret password. How am I doing on time? I think I'm good. To quote Mr. Incredible, I've still got time. Good. Okay, so this is our dashboard, and it shows you your data sets. So here's all my data I've uploaded, or some of it. Here's some sessions I've run. Here's some models I've built. So if I go to my data sets, I could add a data set by clicking this, selecting a file, and then just uploading it. Right? I'm not going to do that. I've already done that. Because I've got monthly Bigfoot sightings. So this has 804 rows, one for each month from 1950 to 2016, and 2 columns. And you see here is our column metadata. We've got the quantity and the timestamp. And this is the same stuff we saw in the spreadsheet. The quantity is numeric, and it's the target. That means it's the thing we want to predict. And if the quantity is missing, we assume it's zeros. The timestamp is a date. Its role is as a timestamp. We've got other roles here. Things can be. They can be. Let me click on it here. A target, a feature, or none. You can turn it off. Our types, we can change those. We can have a measure, a numeric, a string, which would just be text to be used for categories. A logical, which would be a Boolean, a date, or a text field, which we would be using for natural language processing. So you can do lots of choices here. We'll discard that. So you can one. You can only predict one thing at a time. Now you can daisy chain those. So like you can build a model that predicts one target and then feed that into another model. But you got to be careful because if you do that too many times, it starts becoming self-fulfilling. It's like being way out. You're way out on a limb, right? And it's just not as reliable. But the idea is the target's the thing you want to predict. Features are things that impact the thing you want to predict. So for this time series stuff, our target is a quantity. We want to predict how many Bigfoot sightings per month in the future. And our feature is when, is the timestamp. We can view the data here. You see here's the timestamp. There's the quantity. And there's, we can go all the way to the end here. Let's go back to 8. So you can see here on 2008, 05, 01 at midnight, in a nice ISO 8601 formatted date, there were 10 sightings that month. And in June, there were 13. So this is our data. I've already uploaded it. And what we can do is we can start a session with this. So we want to forecast our Bigfoot sightings. So we're going to call this monthly. We give our sessions names just so that we can recognize them. This is for us. And then we don't have any values we want to treat as missing, so we'll skip that. So now we get to pick the type of machine learning we want to do. Do we want to do classification? This isn't a classification problem. We're doing forecasting. Not a regression problem. It's not impact analysis or anomaly detection, but it is forecasting. So we'll select forecasting. Hit next. And it says, give us some start and end times. And so I said this went from, this ended at 12/1/2016. So we'll start it at 1/1/2017. And then at 12/1/2019. So that'll give us 3 years of predictions. So I'm giving it a date range. It's going to do that monthly because I'm telling it do this monthly. So do monthly forecast. My data is monthly. Figure it out. Hit next. My target is the quantity. That's the thing I want to predict. There's my data. And I just hit next. And it gives me a little summary here of what I've done. We hit start session. So now what it's going to do is it's going to go through and run all the algorithms that are suitable for this problem. And then it's going to score them, and it's going to give us the results of the one that performed the best. I don't know how many algorithms we actually go through in this particular case. We can see that it's running here. It started, it's pending, now it's started. If I refresh this, see we're 7% done here. And so I'm going to Martha Stewart this. Yes, there's a question? You can do it either way. So in the case of forecasting, our API doesn't actually build a model because we always need to rebuild that model because over time, you got this period of data, right? And then you're going to want to predict, if you're trying to predict sales, you want to predict sales for the next month. And then next week, you want to predict them for the month, next month plus a week, next month plus a week. So you're constantly rebuilding your models. And so we just go ahead and return you, we pick the model and give you the results of that model in one round trip as opposed to building a model that tends to be throwaway. Throwaway is probably the wrong way to think of it, but that's why it works that way. But our regression and classification actually build a model that you can then have an endpoint hit against. And so I'll show you how that works too. What's that? Yeah, so one of the things it does is it takes those 804 records, takes 80% of them and uses it to train the model, and then uses 20% of them to validate, to test that model, and that's how we score them to figure out which one did the best. So we're finished. Thanks for asking questions. It was a great stalling tactic. So, and I've been really lax on repeating your question. My apologies for probably the 2 people that are online listening. We can see here it picked the seasonal mean annual. And so that particular algorithm means we couldn't find any patterns in your data, but we know that the dates have seasonality. And so we basically took the average each month, and then we're using that to make predictions forward. Which, given our data set, is a reasonable algorithm to pick. I'm not surprised it picked that one, partly because it's what it did last night, but also because since there's not a lot of features, we haven't given a lot of features to make predictions against, it's the one that's going to score the best. And so you see here in green is our historical data, and then here's our prediction. And you'll notice it sort of copied it year to year because it's taking the mean monthly each year and then just copies it over. So it's going to keep saying that. But it did find the seasonality in it, right? And here's our actual numbers predicted that we got back. And I've got in the spreadsheet, or in the slide deck here, I've got a picture of this. It's a little easier to see. So this is a Google chart version of it. All the historical data, here's our prediction. We zoom in. This is a bigger version of the thing we were seeing on our website. We see that same historical data, and then we see this seasonality here. If you look, each of these boxes represent a month. And so here's 2017, here's 2018, here's 2019. And you'll notice something about this data. What do you notice? Yeah. Okay. What you'll notice is that in the winter, there are fewer Bigfoot sightings. It's because Bigfoot hibernates, right? Clearly. No. What was your question? I believe they're close. This one here is slightly different. Oh, would it include this prediction here and averaging this one here? I don't know if it does that or not. It might. I just don't know. That might explain the fact that this on the left corner here is a little higher than it is over here. Maybe. But I don't know. I don't know if it does that or not. Looking at the one on the website, it's hard to tell. And this one we got a little more granularity, so it's just ever so slightly different. So I don't know. It's a great question. You stumped me. Yeah. Yeah, it does actually. Let me hop over to that. So here's our mean absolute error and our mean absolute percent error. And so we call that the MAPE, and there's the mean absolute scaled error. I'm not sure how the scaled error is calculated. The absolute error is really simple. This means, on average, we were 2.55816 points off in our prediction of number of Bigfoot sightings. So if we thought there should be 5, the algorithm predicted either 7.5 or 2.5. So it was off by roughly 2.5. So in absolute numbers. And then we just take the difference between what was predicted and what the actual was, take those and average them all. So it's just a mean absolute error. Just the error, get rid of the negative, average them. That's all it is. And the MAPE here, the mean absolute percent error, is just the same thing expressed as a percentage of all the data. Yes, sir. Well, a lot of machine learning is just statistics at scale. I was actually on Quora and someone asked me what's a really fun thing that you can do. What's a really interesting thing you saw someone do with machine learning? And I said, well, I used it to figure out the impact of the X-Files on the number of Bigfoot sightings. And someone asked me that question is, well, how's that not just statistics? And someone responded with, well, what happened is computer scientists discovered math and then called it machine learning. So you're dead on. A lot of this is just statistics that we've been doing for a really long time. It is scaled up because, we've got enough number crunching capability that we can do it at a level that we haven't been able to do it in the past. And so that's really the innovation. The innovation isn't in the techniques necessarily, although neural networks and stuff like that are interesting, and those are kind of new and different, even though they're not actually a new idea either. I mean, I remember reading about neural networks in the 80s. But again, they're scaling up. But a lot of this is just math at scale. So that's a real common question, actually. And so you can tell because I had a prepared answer for it. But that is a lot of it. And so all of our data scientists are really just math majors. I mean, that's, the data scientists at Nexosis are all math PhDs because they're doing statistics. Yes, sir. As many as you want to pay for. So depending on the type of algorithm used, like if you're just doing like a basic regression, each feature starts turning into a dimension. And so, so that scales up pretty quickly. So, I mean, the most I've run through the API has been about 12. I know that people have run many more than that. It's just as many as you... There's two determiners, right? There's as many as you have money to pay for GPUs for, and there's as many as is useful, right? So lots of times, you could throw 5,000 features at it, but 10 of them are really the ones that are actually determining anything. And so you can put lots of features in. Our API, I don't know that we have an upper limit. I know we have a practical limit. I don't think we enforce a limit. But if you try to give 1,000 features, your job's going to run for a really, really long time. And it's going to cost. That said, it's still fairly efficient. I did 4,500 Bigfoot sightings with the text and the classification. And they took about 45 minutes to run through them, but it was all natural language processing. So, which is not bad. It's like a minute for every 1,000 or every 100 records, natural language processing. Yeah, yes, sir. No, our API doesn't do image data. You could do that. That turns into a lot of features, and I'm not sure which algorithm would win. The things that are really good at that kind of stuff tend to be deep learning, deep neural networks, which is not a type of machine learning we've attacked. I mean, we thought it'd be wise to use our venture capital money to not go head on up against Google and find a different niche. But Google's doing a lot of that kind of stuff. But yeah, we can't do the image processing. If you can get meaningful data out of an image, then that could certainly be input, right? But you'd have to take that image and get that data out of it. You could encode it like you suggested, but you're going to get a lot of features, and I don't think it would perform well. Our tool's not optimized for that kind of problem. Yeah, right. You know, if you get an image and the data is there a stop sign in this image? Well, you know, stop sign yes or no. That's a Boolean. We can deal with that. Or what's the text in this image? So you do a little bit of OCR and then shove the text in. You could pre-process it in ways like that, but you can't just hand it like a bitmap and say, is this the letter M or not? We're not good at that kind of problem. Yes, sir. No, the API picked it for us. Yeah, the API tried all the algorithms that we have for forecasting, and it picked the seasonal mean. Actually, it just tries them all. We just brute force it. So if you want to do classification, we kick off 26 jobs, and then we score using these scores over here. We then pick the one that scored the best and give you an endpoint to use, or give you results in the case of forecasting. And I mean, obviously, this dashboard's pretty straightforward to use. It's pretty easy. But we also have a programmable API, a RESTful API you can use. So, any other questions before I go on? Cool. So one of the, I was going to say here about this is we've got this seasonality in our data. It's figured out that there aren't very many Bigfoot sightings in the winter. And it'd be easy to conclude that Bigfoot hibernates, but really it means that we don't have any data. People aren't seeing Bigfoot because we're not measuring Bigfoot, we're measuring sightings. And so our data isn't about Bigfoot populations, it's about Bigfoot sightings, which is a key thing to understand in your data. We don't know whether Bigfoot is out there in the woods or not in the winter. We have an absence of evidence, but that's not evidence of absence. But it's also not evidence of presence. It's just no data. Yeah. Oh, I got it from this wonderful guy, Tim Renner here. He screen scraped it from the Bigfoot Field Researchers Organization, who have a website that where they have cataloged this data. You can upload it as a CSV or a JSON file, which you can do through the API, or you can do through through this screen here. So if you go to your data sets, you can add a data set right here. Okay. So we've got, that's our sightings. So we forecasted Bigfoot sightings? Yeah, sorry. Yeah. Yeah, it can actually. We've actually got the ability to merge calendars in. So you can merge any iCal from Google into your model. You can just blend it in together. And so if you want to put, say, you know, the college football schedule in to predict your pizza sales, you could do stuff like that. There's another one back there. I think so, yeah. I was going to ask a question about football. Bigfoot doesn't like playing in both the clearly, they're big feet. Yeah. 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 Yep. Yeah. 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 And you'd have to do that. Our API wouldn't be good for that kind of problem. You'd need to come up with some other mechanism to tie them together. In the case of the Bigfoot sightings, they're pretty far apart chronologically and geographically. And I mean, we've got 4,500 Bigfoot sightings over the last century, roughly. So I don't think there's any way to tie them together. Well, there might be several sightings, but we don't have the sightings. We have the reports of the sightings. So, so we just have no way of knowing that. So we're going to use. I love this picture. They face swapped Dana and Scully from the X-Files, and they look like an '80s synth pop band. I'm not going to sing any '80s songs because then we'll get a check mark on we'll get a strike on YouTube. But I think it's hysterical. And so we're going to take the same data and we're going to do an impact analysis for the time period when the X-Files is on the air. The idea here is that the X-Files was a show about the paranormal, and so presumably life is going to imitate art. And so we want to measure the impact of the X-Files on the number of Bigfoot sightings. Did they go up? Did they go down? And so impact analysis is a way where you can basically make a prediction in the past and then compare those predictions against your actuals and get an idea of how much of an impact that event happened. So the model doesn't know about the X-Files being on the air. It just knows that in 1994 and back, this was the number of Bigfoot sightings we had. And it can make predictions from that point forward. And then you have the actual data from that point forward as well, and you can just compare them. So here's our historical Bigfoot sightings again. And so here's our data for 93, 94, and 95. And what we want to do is we want to ask this question. What should these have been versus what were they? And so when we run that through the impact analysis, we'll get our actuals, we'll get our predicted, and we'll see what the change is. And this is the actual results of running it. I'm going to do this through our RESTful API. But we can see here in October 1st, 94, which is the first year. Actually, it was 93. But this is the second year, the beginning of the second season of the X-Files. We predicted 2.5 Bigfoot sightings. We saw 7.5. Clearly, there's something going on here. Or no, the actuals were 10. We predicted 2.5, and the difference was 7.5. I said that totally wrong. So let's go ahead and I'll show you how to do that through the API. So how many have used Postman? If you haven't used Postman, how many have used curl? Which would you rather use? I suppose the answer is it depends. But Postman, if you haven't used it, is just curl with a UI. And so it's a lot easier to use. I've got a bunch of pre-set up API calls that we can make. Let's go ahead and just close all tabs. Don't save. There you go. So I'm going to go ahead and just show real quickly how this works. We've got, we're going to do an HTTP GET at ml.nexosis.com/v1/data. And what this will do is it'll return me all those data sets that I have. So just like in the UI over here, where I can go to my data sets and I get this list of data sets, I can do the same thing from inside of Postman. Now we have an API key, which has to be in the headers here. So there it is right there. If I mouse over this right here, it'll show my API key. I'm not going to do that because I don't want my API key spammed across the internet, although I could change it if I needed to. But suffices to say, it's in there. It's just a UUID. Actually, no, I don't think it's a UUID. It's a big hex string, regardless. So I'm going to go ahead and hit send. We're doing a get here. And we'll get a list of, we get this JSON back showing that I got a pizza data set and a Puxatawny data set. I tried to predict whether Puxatawny Phil would see his shadow or not. It was correct, but a broken clock is right twice a day. So it was not a very good model. This is something I was working on there. More pizza data, more pizza data. Here's the iris data set that if you've done any machine learning at all, you probably are familiar with. Determining the class, what type of an iris it is. There's some cardio data. So anyhow, this is a list of all my data sets, right? And I can get particular data sets. I've got a monthly Bigfoot sightings data set. And I can go out there and you can pull that down and look at it. So here is the name of it. Here is how big it is in bytes. It's time series, which means it's date-based predictions. It's good for forecasting and impact analysis. And just other data about it. Here's all that data that you saw in the UI. It's also available here. So if I there we go. Right, and then there's all our records from the 50s on. And it doesn't return them all. It's got pagination, so you can say, well, give me the next set of pages here. Give me the last page, et cetera, et cetera. So, cool. So we got this little API. We can look at our data. We can upload data. Let's go ahead and create an impact session, impact analysis session. And so this is an HTTP post. And in the header here, I've got my API key, and I've got my content type set to application/JSON. If you don't have the content type set to that, the API will complain at you. And then I've got the body here, which is my request. And so I'm saying, do an impact analysis of this data source for these time periods, start date and end date. We want to do that monthly because we got monthly sightings. Our target column is the quantity. We can give it a name so that we can find it later. And then here's my columns. Now, when I uploaded that data, I said this column is a date and it's a timestamp, and this column is numeric and it's a target. I could override those here at this point if I wanted to, so I could actually build multiple models off the same data set, which is kind of handy. But I'm going to go ahead and click send here, and we got a response back here telling us a little bit about our data, and we got a session ID here. The session ID is it's our key to go out and check periodically, see when it's done, because it doesn't respond instantly. So see, here's our status is requested. There's our timestamp. You might remember seeing these on the UI as well. And we can go out and look at this session here. And that's just a get sessions and then the GUID, hit send. And they'll say requested, started, completed. So it's finished already. And here is the algorithm that was selected. I don't know what that algorithm, I don't know how that algorithm works. I don't know that one. There's our name. The raw data for, it's not in this request because it is referenced here in the data source name. So back when I did the list data sets, one of the data source names is that. When I got that data source right there, and so it's been uploaded already. And so I could do a put here and upload data to it as well, but it's already there, so I didn't do upload. And so if we click down here, we got a link to the results. Let's look at the results. And that's just another get. You see we got a p-value of 0.001, and we got some other statistics there. And then here's our results. So for 1993, there's the 5.2112 was what was predicted. And here's just all our predictions in a convenient JSON format. If we go out here and look in the the dashboard here, we can see that I just created an impact analysis on 6/20, and it's completed, and it was off of monthly Bigfoot sightings, and so we can look at it here as well. And show it creates a little plot there for us. There's that 5.2112 we just looked at. So this is the exact same interface. In fact, this dashboard uses the API. So we're eating our own dog food. So we've done this very similar thing, except that we've done an impact analysis instead of forecasting, but we used a RESTful API to do it instead. Yes, sir. Yeah, so this line down here, it's not easy to see, is the predicted for that time period, and then this green line is the actual observations from the data set. And I've turned these into more easy to read charts here. So you see it's taken all the historical data there and then made a prediction at that point, but we see growth in the number of sightings. So clearly the X-Files has impacted the number of Bigfoot sightings. Yes, sir. You could do stuff like that. I didn't. That's a more complicated problem. I just had the Bigfoot sightings, so I ran with it. Our API has a capability if you have like 2 or 3 data sets, you can create what we call views. They work just like database views. They aren't as sophisticated because we're trying not to create a SQL database, right? But you can join stuff together to create virtual data sets that you can then do machine learning against as well. Yes, sir. We're trying to see the difference, yeah. And then we do a little bit of statistical analysis on it to get a p-value to show the impact of it. But yeah, that's exactly what we're doing. And so this red line at the bottom is what the algorithm thinks should have happened for that time period. And the blue line is the actuals that we have. So now we'll go to the real fun one. This is my favorite, is classification. We're going to determine the type of Bigfoot sighting based on the text of eyewitness accounts. So we're going to use some natural language processing. And I'm going to do, I wrote actual code for this using one of our libraries. Unfortunately, it's in Python. I haven't had a chance to make a .NET version of it, but it's not very complicated Python code. Yes? Oh, in here? Yeah, I think it gets hidden a little bit when I zoom. This is zoomed in. This is 1984 to 2012, whereas the whole data set, this is 1950 to 2017. And so what we're kind of showing here is this is 1995, so we got like a flat line for this time period right here, down in like the 2 or 3 sightings range, and it went up like this instead. So it looks a little more dramatic if I were to plot it bigger. But its seasonality isn't as obvious, is it? And what's going on is it's just taking this point here in time and using that historical stuff to make predictions forward. I think it's not as dramatic. I mean, he's got the same seasonality. It's just not as dramatic because we're not zoomed in enough, I think, to see it, and because it's predicting. Like this is between 2 and 3 Bigfoot sightings in that time period, and so it's just not a very dramatic number. And if you look at the historical ones all the way back to the 50s, in here, you can see a lot of them are down in this range here. Whereas when we predict from this future point here, we've got all these real high numbers in the past that are kind of driving it up to make larger swings. I think that's why that's happening. I'm not really positive on that. I'm not a data scientist. So, but I know it's kind of a disappointing result in a way because it's like, oh, it's just a line. And it's like I was expecting it to be way more dramatic than that. But if you look at the whole historical stuff before it, it's kind of flat. I mean, it's bumpy, but you average it out, it's about like, a couple a month. So that's what it's predicting off of. So classification. So here's our Bigfoot sightings. Here's the report and the classes. I talked about these at the beginning. These are the text reports written down by people using English language. And the class is class A, B, or C. I will say that the model that I built is really bad at detecting class Cs because there's not a lot of them in the data set. Most of them are either I saw Bigfoot or I found a footprint. And it's pretty good at figuring those out, but it doesn't have a lot of examples of class C, so it doesn't do a good job of those at all. But basically the way this works is we'll type in a text. I saw Bigfoot out by the woodshed. He was 12 feet tall and covered in hair. I didn't like the cut of his jib. What class is that? Class A, right. I saw Bigfoot. My dog heard a weird sound in the woods. The next day, we found a large footprint by the creek. I said crick on purpose. The Class B, evidence of Bigfoot. And then my grandfather used to tell me about the time he saw Bigfoot back in 1932. He was walking along Moonville Road when he heard a large crash. And that's Class C, right? Yeah. The UFO data has, UFOs, of course, have the close encounters of the first, second, and third kinds, right? Which, honestly, I think is way more imaginatively named. But the UFO data set also has the shape of the UFO that was spotted. And so I'm working on taking all the text of the UFO sightings and classifying the shape of the object from the description, which should be a pretty straightforward problem. I'm also going to take the number of monthly UFO sightings and the number of monthly Bigfoot sightings and put them together in one model so I can say, if on this date there were this many UFO sightings, I could actually build a simple regression model and say, based on the number of UFO sightings, how many Bigfoot sightings should there be and vice versa? Because there should be a correlation there, because I think it's all cultural. It's just us thinking, hey, there's UFOs, and so we go and look for UFOs. So, but we can ask this question, I've got a model that I built already that does this, and we can see. I use the dashboard to build the model, but then I wrote code to use the model. So classification is a little different. The impact analysis and the forecasting, you go through and you give it data and say, just make me a prediction, and then it makes a prediction. And you get the prediction back. With classification, you give it a bunch of examples and say, well, this is a Class A sighting and this is a Class B sighting. And then it builds a model, and then you can go use that model to make predictions. And then you can just keep reusing it. So it works slightly different with our API. And so what I've done is I took this, this is the Bigfoot classes data right here. So here's my text and my class, which is a feature. Well, it says it's a feature, but when I built the model, I have a session here for it. Classification on Bigfoot classes. Yeah, there it is. This is the session that built the model. And then we got here a confusion matrix. It shows how good it was at predicting things. So of the test data, 378 of them that were Class A were predicted correctly. Some were predicted as Class B and some as Class C. And so it shows a matrix of what was predicted versus what you got and the numbers. And so what you expect to see is a nice green bar through here. We don't have a lot of Class Cs, so it didn't do a very good job. It tends to classify them as Class Bs. But here's our test data. That's not good. Hang on. This is our session here. I was hoping it would show us a little bit of details in here, but I don't see them. I created a session. It built me this model. If I go to models here, here's a model classification on Bigfoot classes, and it says it used the SVC sigmoid. Its accuracies here. We've got F1 scores, a bunch of data that was used to score this thing to determine which algorithm was picked, which model was selected. And so I used this API to build this model, but then I utilized the model programmatically. And the code to do that, it culminated in a website. Yeah, what I uploaded was, here's the data I uploaded, Bigfoot classes. And so I've got the observed, that's the text of the sighting, and I got the class, which is Class A, Class B. So if we go in and view the data, a human being did that. And this is the data that was screen scraped from the BFR website. So the data set I had all the answers. And so we give it a bunch of, it's like if we had a bunch of houses and we know the price of a bunch of houses and we're using that to predict other houses that we don't know the price of. So we have to give it examples where we know the answers. So here's the data. These reports are a delight to read. If you ever get a chance to go out and browse a few of them, they're thoroughly entertaining. But what I have done with this is I use that to build a model, and then I've got this code here, which I posted on as an AWS Lambda. And we're using the Nexus API client. And we're getting, from the event, we're getting our text, whatever is typed in. You know, I saw Bigfoot in the woods. This stuff here, right? We get our API key from an environment variable. And then we instantiate our client. And then we can predict multiple rows. We can do multiple predictions at once, but we only want to do one. So we've got an array. And then that array has a bunch of dictionaries that have key value pairs for the all the features. We have one feature, which is the text. And so we shove that into the observed. We go out and get our model ID. And then we make a prediction. Nexus client.models.predict. That model ID goes right there. We pass in our features. And we get results back. And the C# version of this is very similar. We get results back. It's got a data property, which is an array of all our results. We have one thing in our array, so we get the first item. And then we can shove that into a new dictionary, which we then return. And then that gets turned into JSON on the back end. So we got JSON coming in, JSON coming out. And we're just calling the Nexus API from Amazon. Yes, sir. Yeah, depending on the algorithm, we will return back our confidence in all. We'll say we're 87% sure it's Class A, 27% sure it's Class B, and 2% sure it's Class C. And so you'll get a kind of an idea of what that is. Now, I don't use any of those because this is simplified, but that is data you get back. I think in some cases you don't, but in most cases you get that back. And it's not actually, with the Nexus API, it's not really a percent. It's a score relative to each other. So it's not actually a percentage. Other APIs use percentages. And so I built this Lambda, and then I use it to build this site. So I use Vue.js to wire this up. Vue.js hits the AWS Lambda endpoint, and the AWS Lambda hits the Nexus API, uses the model, all the data comes back. So data goes out, data comes back. And this is actually live in production. By production, I mean GitHub pages. And so I can actually show it to you. So here we go. This is the Bigfoot Classinator. This is the source code. You can actually go out here. If you Google Bigfoot Classinator, I've got the only site on the web called this. So, but the source code's out here on GitHub. So you can go browse that. And so let's take, where are we at here? Let's take that one. I saw Bigfoot out by the woodshed. He was 12 feet tall and covered in hair. I didn't like the cut of his jib. And classinate that sighting. So now it's hitting Amazon. Amazon's hitting the Nexus API. And then Nexus API is making a decision. And then it says, you saw Bigfoot. That's the Class A sighting. Do the Class B. This is the large footprint by the creek. Analyzing your sighting. This one should be faster because the AWS Lambda hibernated because no one has called it in a day. And it says you found some evidence of Bigfoot like a footprint. That's a Class B sighting. So, does anyone want to make one up? Then it doesn't know. It gets it wrong. It'll try. It'll try. I mean, the way to think about that is if you take, a bunch of contradictory information as to whether you saw Bigfoot or didn't, and I asked you to classify that. Yeah, that would make sense logically. I don't know that it's going to figure it out. Our natural language processing isn't super advanced. There's more advanced techniques. And so we use a couple of them. It determined it was Class B, which is wrong, right? It probably won't matter. because I think it's doing a bag of words. Yeah, it still found it as a Class B. So, what's that? Yeah, a lot of these words, it's gonna. I bet you, if we just do this, that will probably be a Class B. Because it's not actually. I mean, it's not real. It's not understanding English, right? It's just doing statistics on words in a sentence. Yeah. Yes. Sir. You want to type it? I saw Bigfoot, Big Boot. I love that when I hovered over it, it said Big Booty. I don't know if you saw that or not. See? I saw Bigfoot or my Uncle Larry. They are both really hairy. So I'm not sure. There we go. Oh, you said Harry, not Larry? Okay. Harry is better. You can't trick it with homonyms because it doesn't know how you say the words. It's not that smart. Well, that's funny. Harry made it a class. Yeah. I saw a big hairy creature, or my Uncle Larry. You don't have to put Bigfoot in there. Well, and and so we could play with combinations of things in this all night, right? And it's kind of fun, and it actually works on your phone. So if you want to hit the site, you're welcome to. But you had a question? Or okay, yeah. How do you build a model? Through the API here, or through the REST API, or through the dashboard. You can go to here, and so I've got this data. I can start a session, and I can say, I'll just leave the session name out, and I say I want to do classification. No, let's not balance the test set. And then I can say I want to predict report class. And then I can hit next. And if I click start session, it'll start running this thing, which will take about 45 minutes, so I'm not going to do it. And then when the session's done, my output will be a model ID, which I can then use. Make sense? Okay. And you can do these exact same things through the API. And you can also do the exact same thing through the API clients. So if you wanted to write C# code that dynamically created models for each user, you could totally do that. The front-end code for this was all in JavaScript. I'll show you that code here super quick, and then we'll wrap this up. I have gone a bit long. Where is it at? There it is. So under site here, that's where all my code is for the site. And here's the index.html. If you've used Vue.js, then this will be real basic code for you. I'm not like a Vue.js expert. Yes, sir. So can it learn from the data that options you give it? You can do things like that. Our API doesn't do it. That's called a batch versus online machine learning. And so batch is, hey, I built my model, and then my model's frozen in time. and online is it learns as it goes. So in our for Nexosis, we only do batch. We don't do online. But that is a thing you can do. So here we got our code here. There's a V model saying bind this to the report text. Here's onClick. It calls the classinate function. There's the classination, which is our results here. And this is all just view code. If we look at the app.js, we can see that here's our URL against Amazon. Anyone can hit it. It's just open to the public. Here's our messages. So if you get a class A back, we display this message. You get a class B back, you display this message. It's just a little lookup table. A couple other messages that are in strings. And then what view does is it binds to the element that has the ID of app. And then you define your data. We got a report and a classination. Those are our two. That's our text box and our result. And then we've got some methods. There's only one method. It's called classinate. And so when we click that classinate button, it triggers this function right here that's highlighted. And the first thing we do is we say, we put a wait message out for them to read, which is just updating this variable. And then we use Axios, which is a tool that works with Vue to do AJAX calls. We do a post against the URL, passing in this JSON object. This report is bound to that, which is the text box that was on the page. When that resolves, the promise resolves, we get a response back. We pull the report class out of the response, which is the stuff from the Python code earlier. And then we take that response and look up the message we want to display and put it on the screen. If there's an error, we do nothing. We log it and move on. So that's JavaScript code. One interesting, just a moment. One interesting thing here I wanted to show is that a lot of people don't know this about GitHub, and I didn't either. But how many people have a website on like GitHub Pages? Right? You can just have, your username.github.io as a repo, and it works. You can actually take other repositories and put them as GitHub pages as well, and it will put them in a folder under the repository name on that site. So you'll note that the Bigfoot Classinator is at guyroyce.com/BigfootClassinator/site. You probably can't read that, but trust me, that's what it says. And that is because in my repository that we were just looking at, we'll go here. Source code. That is called Bigfoot Classinator, and there's a folder called site. So this is actually the live code sitting here in the repository. And if you go into the settings on a repository in GitHub, you go down to GitHub Pages, you can say, publish this on my site as this folder. And so you can say, pick the master branch and put it out there. And so you can take other repositories and have them be sections of your website on GitHub. So kind of a neat little trick there. And yeah. Oh, it's just for fun. Classinate is just because yeah. No, it's not a technical term. It's a silly term. I just thought it was funny. It's not a Bigfoot classifier. It's a classinator. Yeah. So let's move on here. There's the classinator. So we talked about forecasting, impact analysis, and classification, how to do them with the Nexosis API in a couple different ways. This is the slide I have to say, hey, could you go check out our stuff? Accounts are free. You can get up to 20 data sets at a time. You can delete them and add more. You get several thousands of calls every month, and so you can prototype stuff and play with it, and mess around with getting some machine learning into your application if you want. And then if you want to start scaling up your app, you can pay for more usage. So go out and sign up. It helps us out a lot. And that's me. And that's Nexosis. And those are the people I stole the images from. Any questions? Yes, sir. Straight up what? There are some neural networks that we do as well, but most of them are statistics and math. It depends. I mean, if you're doing classification, then it's using different types of algorithms. Whereas if like you're just doing a classic regression problem, then it's just regression analysis, and it's like you can just do linear regression sometimes, and that's sufficient. But yeah, a lot of this is just math behind the scenes. Yes, sir. Yeah. We're based out of Columbus, Ohio. Yes, sir. Developers. But yeah. So the question is, who are our target customers? My answer is developers. That's the short answer. What we're trying to do is, how many people have used Unity to play around with writing some video games, right? You're like me. It's like, oh, I played with it a little bit, but I haven't really done much with it. But before Unity, if you wanted to build a video game, you had to go out and spend an infinity amount of dollars on like the Unreal Engine. And so you just couldn't do it. Then Unity came out and said, hey, you can play around and write some simple games. It's way easier to do now than it was before. You don't have to do all this 3D math. And you can play around with it for free. We've made it easy to do. And if you start making something real with it, then pay us. And what happened as a result of that was there was an explosion in indie games. And so I don't know how many of you play video games on Steam, but probably a lot of people, right? I plan on playing video games on Steam tonight. I'll probably play Cities Skylines and stay up till 2 o'clock in the morning. But and so we're kind of trying to do that same thing for machine learning. If we can make machine learning easy to use for developers and easy to incorporate into their app, then they can put it in their app and they can do interesting things with it. And we don't know exactly what those interesting things are yet, but it's trying to make it more accessible to developers. Now, that, of course, will translate to enterprise sales as well, right? Big companies can make use of this as well, but our core audience we're trying to reach is developers. We're kind of doing the same thing like Twilio did. It's a very similar sort of approach where they're trying to get developers using their product, and that eventually leads to, someone says, hey, how do we do this thing? And someone says, oh, I know this product that does this. And so, yeah, we're totally targeting developers. So, which is why I'm here. Yeah. Well, not game programming specifically, but it's a parallel sort of pattern where the game programmers went off and they had this tool, and then there was an explosion of all these games, whereas before there weren't as many. And we're kind of hoping we can do the same thing, but for machine learning. Well, the word AI doesn't mean a lot. It usually just invokes images of scary cyborgs with Austrian accents, right? Machine learning is, a lot of it is math, but some of it is neural networks as well. And deep learning is a type of machine learning. And like Watts is using deep learning. And you can do a lot of things with deep learning that you can't do with our API. We like a lot of the image recognition kind of stuff. Does this picture have a cat in it or not? That's a good problem for deep learning. Is there a stop sign, right? How many of you had CAPTCHAs lately that ask you, click on all the buses in this picture, or click on all the cars in this picture, or click on all the stop signs? It's annoying, but you know what they're doing? You are training machine learning models for self-driving cars. Because they need to have a bunch of pictures and say, this picture has a stop sign in it, this one doesn't. Just like with our Bigfoot sightings, we had to have, this is the text and this is a class A. You got to label that data. You have to know the answer. We're doing something similar. So, yes, sir. Yeah. Yeah. A model is the result of having run of machine learning. Got all this data, and I want to, I pick an algorithm, or in our case, we pick all the algorithms, build models for all those algorithms, and then score them. And the model is the thing that you want to use to make predictions against. The training of that model is using all that data. And it's the thing that finds those patterns. The training is where that happens. And so if you got a lot of features and then the thing you're predicting, and it finds the features that impact that and finds the shape of that curve. And we actually will score the features. And so if you got features that aren't very good, they'll drop off on the bottom, and ones that are really highly correlated will show up on the top. And so you can do a little bit of finessing with that. Well, that's the magic of it, right? That's the thing that machine learning is doing. So if you, depending on the algorithm you pick and the features you've selected, it's going to figure out how each of those features impacts the target. And then it's going to build a model that takes all that into account. So then when you put in features, yeah, and it can figure out which is important. Yeah, it can figure out, I didn't show it, but deep learning's a little different. Yeah. Yeah. Right. There are ways that you can still figure out which attributes are important simply by running them through the model. So like you can just like take an attribute and set it to 0, or set it all the same, and then say when I run it through here and say this feature is all the same, I get these sorts of outputs, and when I vary it, when I scramble it, and then you can measure the impact of that feature by basically by poking the model. So there are ways to do that. Of course, the answer is it depends. So the amount of data you need does totally depend on what you're trying to solve. I will say that people often think they need way more data than they do. They're like, well, I need 10 million records. It's like, well, no, you don't. Right? If you've got a bunch of log entries, and you've got like CPU utilization and memory and stuff like that, and you're trying to find out whether the server is acting weird or not, you don't need all 10 million entries over time, because it's already found that curve, and you're just recalculating that curve over and over again. You're just wasting GPUs. You're just creating waste heat. You're contributing to global warming. Shame on you. And so it does depend. The more features you have tends to suggest that you need more rows, because it's hard to cover all your bases. So whereas if you got a couple features, you don't need nearly as many rows. So. Yeah, you can't just throw a bunch of data at it and have magic happen. You still have to understand your problem. Like if you're trying to predict pizza sales, you're probably going to want the weather, because when it rains, people order pizza. You're probably going to want to know the date time, because the day of the week has an impact on pizza sales. But there's other things like that might not impact it. That so you kind of have to know that. That's actually a lot of what data science is figuring out what data matters and what doesn't, and getting rid of outliers, and coming up with ways of taking your like, say one of your attributes is inches of rainfall. You can just put that as a number. But it might be more useful to put it into buckets and say, well, was there more than 4 inches of rain? Well, that's a lot. Actually, that's a bad example, but but or was the temperature above a certain point for determining, or below a certain point? That might actually give you better results than if you just use the raw number. And so data scientists can figure that kind of stuff out. Ages, you can put an age in there. It's just a straight up number. But sometimes what you really want to know is not how old they are in absolute terms. You just want to know, are they young or old, right? And so, are they a kid? Are they a young adult? Are they middle-aged? Are they, over 60? And so those ranges are sometimes more useful. So it depends on, and that's the art of both knowing your domain and of data science. And we don't solve that problem. You still have to understand your data. There's still value in being a data scientist. I've been cut off. Nah, it's me. There we go. Sorry about that. My screensaver kicked on. So, yeah. I'm sorry? Yeah. Yeah. Yeah, yeah. Yeah. Yeah, that's exactly what you do. If you're below a certain threshold, it's free. And then after that, it scales up to higher cost. Our pricing model right now is here's our free tier, and here's our call us for a price tier. I think so. I mean, if your app became really popular, then you might start exceeding your thresholds. But yeah, you could totally do that. That's actually probably a classification problem. I'm gonna go to the back there. No, you don't. We deliberately did not require people to give credit cards beforehand because everyone hates that. If you exceed your thresholds, we'll say you can't make that call. You'll get some 400 series error. Yes, sir. Yeah. Well, we've got people are using it for a lot of different things. We're doing some work with Wendy's at one point. I think I can say that publicly since I don't think we're working with them anymore. Well, it wasn't Wendy's corporate; it was a franchisee, and we were measuring the impact of promotions on their sales at different stores, and we're able to determine that like 20% of their stores weren't impacted by the promotion at all, which is good to know, right? I wish I could remember the name of them, but they're a marijuana dispensary, and they've got a model they've built that they use for, I don't know what they're using it for. I just know they're like, I think it's like headset.io or something, or headshop.io. It's something head in it. I can't remember. But so we do have paying customers using it, which is good. I mean, we're a startup, so that's a fair question to ask, right? Yes, I'll get to you next. Not today, no. I will say that once your model's built, it tends to go fast. Building models is slow, but once your model's in place, it's fast. Right, and we did it, and it was in real time. Yeah. Now building that model took 45 minutes. So, and you can build anomaly detection models as well. So, yes, sir. We can do some basic feature engineering, like we'll do the imputation and the aggregation of data, and we'll tell you how impactful a particular feature might be. But we just do some real basic stuff. We don't do real high-end feature engineering, like I was talking about how you could bucket your data from a number. You'd have to do that yourself, that kind of stuff. I know it just does it. Yeah, it just does it automatically. Yeah, so if you wanted to predict monthly, and you provided like just the absolute dates, like on the 3rd there was a sighting, and on the 5th there was a sighting, it would collapse them together for you automatically. Right, exactly. So it does that for you automatically, which is handy. So, well, if there aren't any other questions, I think I'm going to wrap up here. I'll be hanging out here for a while, so you can. Well, there's a lot of people sitting here and they're like, "Can we leave yet?" so I'm happy to answer questions, but if you are tired of hearing me answer questions, you are welcome to get up and grab some more tamales. I will not be offended in the slightest. so.